So here's another example here. We have, remember you have to identify what type of compound you have. So when you split it down in the middle, you notice that there's a transition metal, and on this side you have more than one element, so that means you have a polyatomic ion. So again, you have a transition metal polyatomic ion compound. So to name it, we're going to, remember with the transition metal you don't know its charge, so you have to identify what the charge is by looking at the total charge on the anion side. So like we did before, you split it down the middle, which we've already done. You're going to put a multiply sign on this side and a divide sign here. You're going to find the charge, or the oxidation number for C2H3O2, what's inside the parentheses. That's a polyatomic ion acetate. When you look on your chart, it tells you that acetate has a charge of -1. So you're going to take -1 and you're going to multiply it by how many acetates you have. So you already have the parentheses with a 2 on the outside. That means that you've got 2 acetates in this compound. So -1 times 2 gives you a -2 charge. That total charge, that's the total charge of the anion in this compound. That total charge is going to move up on top here, and you're going to divide it by how many coppers are in the compound. So you just have, there's no subscript here, which tells you that there's only 1. So you're going to divide -2 divided by 1, which is going to give you -2. Since copper is a cation, meaning it has a positive charge and it has to counter the -2 charge, you're going to change this -2 answer into a +2 here. And when we name it, you name the metal first, which is copper. It has a +2 charge, so you have to put the Roman numeral 2 after the name, and then you name the polyatomic ion, which is acetate. So copper 2 acetate would be your final answer.